for today, I'm not going to spend more than 10, 15, 20, maybe 30 minutes recording this because my body is just not responding as well as I want to, and just needs more rest. That's just the main thing. I just need more rest. But there are some things that I did behind the scenes that I'd like to show and share with you, as to and even explain to lock in what I was exploring, lock it in by being able to explain it. And what I did with this project is that I want to create a spiral clock where there's every 6 degrees of the 360-degree circle, every 6 degrees is a second. So 1 second would go 6, 12, 18, 24, etc. And what I needed to know was actually how to find a point on the circle, an XY coordinate on the circle. I didn't know. I got so overwhelmed. I was not in the mood yesterday, so I did pack up and leave early. I am grateful that I did do it, but I didn't follow through on any of it. So after some sleep, I woke up and I really did just get to work. I was like, you know what? Today I gotta rest. But I'm gonna be resting for the rest of the day. I started going to some of the math sites, just like this one, the hypotenuse, the opposite, adjacent, finding the sine, cosine, and tangent, degrees, lines, other calculators that are available online, and I think I found it and am able to create. Come on, Libra Calc. Let's go ahead and. Okay, we're gonna save this. Not notes. I want to save it in that place. Oh, there it is. It's like, what? No. Yes, yes, and this will be. Saving in a certain way. June 14th today. Okay, so using LibreCalc or Excel, an open Excel software, I think there is an easy way to figure out every single 6 degrees because I do not know how to do it manually. There may be a way to do it. Way to do it automatically. There may be a simple formula I can plug into here that it will calculate the XY coordinate for me without me having to manually do it. And maybe for me to get there, I have to know the process of obtaining that information, not just copy and pasting. Again, I may have to go through the difficult route, but this is the route that we're going to go in. For now, I can always just keep going. Get something, and then you can modify it from there. So from here, I was trying to figure out, where are you? No, where'd it go? There it is. Yeah, there it is. With the circle that I was creating, I wanted to figure out what a degree was. The goal I had from yesterday for today was just to figure out one XY coordinate that is on the circle. So what I was trying to figure out was how do I find and/or scale a 500 radius, a 1,000 diameter circle, rather than a 0, 1 to -1, rather than a 2 diameter or 1 radius circle. I needed to scale it. So my question was, how did they find the blue and the green number? Those, I didn't know what to do with them. I mean, it's very simple math, but I didn't know how to do it. Because if I don't have any reference and I'm trying to pull from it emotionally, I'm literally grasping at straws and not getting anything tangible, which then modifies how I'm feeling for the next thing. Again, behind the scenes, I was very cool, calm, and collected, but while I'm expressing myself, this is what's going on the inside if I'm not expressing it. Or this is just how I'm expressing it and need to change how I express it. Wow, I love expressing it out loud, man. Again, on the inside, I was cool, calm, and collected, but these were maybe some emotions. Or maybe it's just how I'm expressing it, which amplifies what I was thinking and feeling in either a good or bad light. It's just I get more emotional when I express myself. Who knew? Oh man. Yeah, again, that's I need some more. Yeah. So my question was, so I came over here to a practice. So this sine, cosine, and tangent, I was curious of how to do sine. Sine was the one that was right here earlier, and I just solved it. So the cosine is the hypotenuse divided by the adjacent, or the adjacent, no, it's the hypotenuse divided by the adjacent, or something or another. So I wanted to go to sine. Whatever it was, I went up here, excuse me, and it's opposite divided by hypotenuse. Come on, highlight, there we go. Opposite divided by the hypotenuse. And there is good news. I didn't know this before. I didn't know how to do the hypotenuse. I didn't know how to do the sine if I only had one sine. If I only had a degree and one line, the radius of 500. Now, I would like to point out that all the calculations that I've made so far were for a 500 radius circle. I forgot after I solved that is that I actually have a 375 radius. Like it's not 500, it's 375. So I have to go through the whole modification. I have to recalculate it. But I am able. Here's an opportunity for me is that I'm able to express and go through the entire process from start to finish of figuring out what the 375 is. So in mathematics, it's very simple to find if you have 2 out of 3 facts, numbers, symbols, something, you have 2 out of the 3 values you need. The third value you do not know. All we have to do is isolate that one variable. That's all we have to do. If we have all variables except for one, we can figure out that one by modifying which side and by isolating that one value. I didn't know what the opposite was. I only had the hypotenuse, which was my radius, and the sine and the degrees, which I picked was 60. I could have done any number, but that's the number that I chose to do. So I'm going to go over here, and I'm just going to, because I have all the notes over here from start to finish. I'm going to go in order, but these are the wrong numbers for a different value set. I need to go and redo all these calculations with a new value set. Rather than 500 of a radius, I need to do 375. So I'm going to do is what are the known points on the outside, which is all these coordinates are these circles on the outside of the circle. All these small white dots on the outside of the circle. Rather use dots rather than circle. So I don't just keep using circle, circle, circle. So what do cosine and sine do? Like, I didn't know what that means. This is irrelevant information. This, cosine, sine, tangent, all this is irrelevant information. The process of elimination. Because what I have right now is the radius. So at the very center of this circle, let us go here and bring this circle square root of that. Let's just make it 500. 500. Save, play. So this circle right in the center, we know what that coordinate is. It's 500, 500, the xy coordinate. The radius of the circle you see here is 375. The entire gray background, the canvas, is 1,000 by 1,000. Just some numbers to throw out there. I'll do my best to be as consistent as possible, making as little errors as possible. The coordinate right in the middle is 500 by 500. The radius is 375. That is the hypotenuse from, if we're going to use a coordinate up here on the top right-hand corner, if we're going to try to find this coordinate, we're going to need what the hypotenuse is, because the right triangle is going to come down. Let's get paint. Again, my microphone is in the, okay, there we go. So if we have a circle here, no, that's not right. Where's, okay. Horizontally, yeah, okay. It's not perfect, but we'll just go with it. Okay, so this hypotenuse right here is is the radius. The radius that we have is radius hypotenuse equals 375. That is what we know already. What we also know, what are all the known factors? The degree that I was looking for, again, I'm just pulling a degree out. I can use any of these degrees, 60, 45, 30, 150, 210, 300, 275, or 0, even 9. No, it doesn't matter. I'm just picking a number. I'm picking a degree. I can use any. I'm just picking one. And then every calculation we do is going to find the other numbers associated with that degree set. The degree is our independent, while all the other ones are dependent on that calculation. Once we change the degree, all the other calculations will change. The hypotenuse, the radius, regardless of what degree we have, that is a consistent. It will not change unless we change the size of the circle, which we're not. So the degree, we're going for 60, just 60 degrees. We're going to use sine. So sine, let's put x, equals opposite divided by hypotenuse, by Popo. So the degree, so when we do sine, we're looking for the information we need is to have the inside degree, which is 60. We know that. We know the hypotenuse, which is 375. We have an unknown variable, which is easy to solve, which is something I was trying to think about this morning, like, what? Something I remember in mathematics way back in high school, so high school is now paying off, is all we have to do is that on one side, it's opposite divided by hypotenuse. So we will need to multiply both sides of the equation by the hypotenuse, which will eliminate the dividing hypotenuse, and the multiplying hypotenuse will cancel each other out and go away. So what we're now having, okay, is, dang it. Okay, let's just go with it already. It's not what I wanted at all. Okay, so sine 60 equals, come on. Sometimes this gets annoying. So I'm trying to do a certain thing and it goes somewhere else, and learning to let go and learning to move on. That's a difficult thing but it's so necessary. So sine 60 degrees equals, we're going to do times the hypotenuse equals the opposite. So what we have is sine 60 times 375 equals something. What is that thing? Okay, so we're going to do 60 6. Uh-oh. Okay, it's probably because of how, if it calculate of, um, no, my computer's not responding. Uh-oh. My keyboard is not responding. That's not good. I'll be back. Oh, this sucks. It's a wired keyboard. It's not a wireless. What the heck? Yeah, that's not good. Okay. Okay. I don't know if you can see me. You can hear me, but my webcam is now not working, so I'll be back.